and welcome back to the channel. So before we start, I would recommend you subscribe to the channel if you haven't already. You will find tons of amazing hands-on videos on DevOps and Cloud DevOps. So make sure to subscribe. Also team, for those who want to prepare for DevOps interviews, you can enroll to batch 6, which is starting after 2 weeks, that is 30th of July. Okay. And also as of now, we are having early bird discount. So total cost will be coming, which is 7,500. Talking about the projects that we are going to cover in this course. So total 10 hands-on project that we are going to cover, basically do implementation of different kind of projects. If I explain you, first will be like Java CRUD based or full stack application. Then we will be having Node.js full stack application. We'll be having a portfolio website, how to build and deploy. Then we'll be having a virtual browser project. Then we'll be having a multi-tier project. So 3 multi-tier project we are going to have, where I'm going to show you how to integrate database with application. So in one project, I'm going to show how to integrate PostgreSQL, then MongoDB, then MySQL. After that, we are going to have a microservice based application, basically 10 microservices based application we are going to have to understand how exactly microservice based applications are built and deployed. Then we are going to have a real world Java based application. Then we are going to have .NET based application, which is going to be used for monitoring. And then we are going to have a Python based monitoring application. So basically, if you understand that almost all kind of different languages based application, microservice based application and multi-tier application we are going to cover in the project. Okay, and as you can understand, this is going to be really useful. So if you're interested, you can enroll. All the details will be in the description. Okay, coming to today's topic. So today we are going to learn a very important thing, which is about the real-time workflow in companies, like how exactly in companies each tool is being used, what kind of pipelines we are having, what are the different stages. So I'm going to explain line by line and detail so that you can understand everything very clearly. Also, this video is going to be really useful for interview point of view, because in interviews, if you understand each flow, if you understand each tool, how they are being used, then you can easily explain in the interview. Okay, so yeah, with that being said, let's get started. So team, now we are going to understand in real time how exactly resources are created, how exactly we write pipelines, what kind of stages we are going to have, and why do we need those stages. Okay. So first of all, let us understand that, when you are working in a company, the first thing that is going to happen is the creation of infrastructure. Basically, if you want to build and deploy an application, so what you need to have? You need to have source code repository, you need to have a deployment cluster, you need to have some tools for example, like Jenkins, SonarQube, Nexus, and all those, right? So first step is to set up those things, right? So first step is to set up infra. How we can set up those things? One option is that we can manually do everything, right? But it might be very time taking. Second option, first one is manual creation of infrastructure resources, right? Second option is basically automation. Okay, why do we need automation? Because it's going to save a lot of time and it becomes very much easier to create resources and manage them. Okay, how we can do that? So for automation, we have one option which is known as IAC. IAC is short for infrastructure as code. Basically, inside IAC, what happens that instead of manually creating any resources, we will write some code. Okay, inside this code, what will be there? The configuration of resources we want. For example, let's say I want to create 3 virtual machines. So inside the code, I will write that I want 3 virtual machines. I want them to have 25 GB of storage. I want them to be of size T2 large. Okay, so this kind of configuration I can define in my piece of code, and then I can use some other tool to create the resources. Okay, what is the benefit here? So let's say next time I want to say that, okay, instead of 3, now I want 6 machines. So I can simply update my code to 6. I can just write there 6, and using tools like Terraform, I can execute, and immediately 3 more virtual machines will be created, right? You can see how easier it becomes, right? So let's say using Terraform, what I'm going to do, let's say using Terraform, we can create EKS cluster where we are going to deploy our machines, deploy our applications, and we can create certain virtual machines also. Let's say 3. On one virtual machine, I will install Jenkins. On second virtual machine, I will install SonarQube, and third virtual machine, I will install Nexus. Okay. Now using Terraform, we can create the resources, but when it comes to like configure them, by configure what I mean, that I want to install these tools on these virtual machines. So best tool for that is known as Ansible. Okay. So these two tools, Terraform and Ansible, these are like 2 best tools for IAC. Okay. For Ansible also, like let's say I want to install these tools. So what I'm going to do, again, I'm going to create a script. In case of Ansible, it's known as playbook. okay, that code. So inside this playbook, I'm going to write that, okay, on first machine I want to install Jenkins, on second machine I want to install SonarQube, on third machine I want to install Nexus. Okay, in detail format we need to write everything. Okay, so once we have written that, then using Ansible I just need to execute it. Okay, as soon as this execution of playbook is completed, automatically on these three machines Jenkins, SonarQube and Nexus will be pre-installed. Okay, now what is the benefit again? So let's say someone says, okay, I have around like let's say 27 machines and I want to install like on 9 machines Jenkins, on 9 machines SonarQube and 9 machines Nexus. So similar kind of playbook I can create and it will be very easily done, right? So using 𝗖𝗍, what happens? It saves a lot of time and it keeps everything easier because all the configuration will be stored inside code. So later on, if I want to modify anything, if I want to delete anything, I just need to make changes in the code, right? So it's very much easier. Also see, using Terraform, if I'm creating EKS, creating EKS is a long procedure. Let's say manager says, okay, you need to create 3 clusters, one for dev, one for PPD, one for prod. Okay, there are 5 clusters generally, but let's talk about 3. Okay, so here, if we have 3 clusters, then using Terraform configuration, I just need to run it 3 times by changing the name, right? One for dev, one for PPD, one for prod, and easily in few minutes 3 clusters will be created specific to these environments. Okay, so this is how 𝗖𝗍 works and this is how we can create resources and configure them. One more thing that you need to understand very clearly, Terraform is best for provisioning. Okay, I'm not saying that Terraform cannot do configurations, but it is best for provisioning resources. Okay, Ansible it's best for configuration management. Okay, again I'm saying that using Terraform you can create resources, you can configure them also, but Terraform is best suited for provisioning resources while Ansible is best suited for configuration management. Okay, now so let us say once we have created this all the tools are created, EKS cluster is created, Jenkins created, SonarQube and Nexus created. Next step would be to create pipeline for doing the CI/CD, right? But there is also a proper flow in that. Okay, for example, let's say application is running. Okay, let's consider a scenario where our application is deployed. Okay, then client will say, okay, I want to update the application, I want to add some new features. From there, how CI/CD will be done, that I'm going to explain now. So team, now let us understand the actual CI/CD pipeline and how does it work. Okay, so basically what happens, let us consider a scenario that our application is already running in the deployment cluster like EKS. Okay, then after a few days, a client says that, okay, I have a new requirement, I want to add 3 buttons in my applications. Okay, 3 buttons of, let's say, black color or something, some kind of any requirement that client is having. Okay, so how from this requirement, how this feature will be added in our project. Okay, so as soon as client says, okay, client will discuss among themselves that, okay, we need to have 3 more buttons for the application. After that, client is going to raise a ticket. Okay, ticket is basically it's going to be a Jira ticket inside which a detailed information will be there about the requirement. Like, okay, client will write, okay, we need to have 3 buttons on the application. As soon as that ticket is raised, what is going to happen next? A developer who is supposed to write the source code for the application is going to take that ticket in his name, basically assign that ticket to his name, and he's going to start writing the code for 3 buttons. Okay, now why we need to have ticket? Basically to track the work, because if client is saying, okay, we need to have some three buttons, that is a kind of work and that needs to be tracked, like who is working on that task, right? So for that reason we need to have tickets for properly tracking the work. Okay, so as soon as ticket is raised, developer is going to take that ticket and he is going to start writing the code for those 3 buttons. Okay, let's say a developer has written the code for 3 buttons. Now before the code is pushed to GitHub repository, it is going to be tested in developer's local machine. Local machine is like developer's laptop. Okay, as soon as developers has written the code, he is going to immediately test the piece of code in their local machine. Okay, so once they are sure that, okay, the code that I have written, it is working fine, then they are going to push the code to GitHub repository. Okay, now as soon as the code is pushed two option can happen. Okay, one is like the pipeline will be running manually, that means we need to trigger the pipeline, or we can automate it. Okay, automated is basically means that as soon as code is pushed, automatically pipeline will get started. Okay, this automation we can do using a feature known as webhooks. Okay, once you configure webhooks, that means that as soon as the new code is pushed to a specific branch, then that specific pipeline for that branch will start to trigger. Okay, start to run. Okay, now what are the stages that we are going to have in our pipeline? First of all, what is going to happen is git checkout. Okay, git checkout is what? Git checkout basically means that we are going to create a copy of the application code that is present in GitHub. We are going to create a copy of it inside Jenkins workspace, because if Jenkins need to work with this application code, they need to have it a local copy. So immediately Jenkins is going to create a local copy that will be existing inside Jenkins workspace. Okay, as soon as git checkout is done, next step is to install tools. Okay, what is install tools? For example, let's say I want to use Java, I want to use 𝗘𝗅𝗰𝗋𝗃, I want to use any other third-party tools or Node.js or any kind of tools in my pipeline. So we need to make sure that those tools are installed. So after that, after git checkout, those tools are going to be installed. So team, once we have installed all the tools needed for the application to work well, what things we are going to need? So after that, what we need to do, we need to compile the code. Basically, compilation means what? Compilation means we need to check that if there is any syntax based errors or not. For example, let's say you might have let's say we might have missed in our piece of code somewhere like colon or any kind of like syntax based errors. That is what compilation does. Compilation checks if there is any syntax based error or not. If compilation fails, that means immediately you need to check your code, because some issue might be with the code, okay, in syntax. So once we have completed the compilation part, automatically next step will be triggered, which is to run unit test cases. So testing team might have written unit test cases to run test cases so that we can test out the application. Okay, so that will be running like after compilation, unit test cases will be running, okay, to generate a test case report. After that, what we want as part of like DevSecOps, what we want that the application code that we have inside our repository, that should be scanned. Two kind of scanning will be done. First scanning is going to be FS scan, which is file system scan. So whole files are going to be scanned to find. 𝗘𝘅𝗰𝗋𝗃 is a kind of tool that can perform this kind of vulnerability scanning. So 𝗘𝘅𝗃 is going to find if there is any sensitive data stored in the code or not. Okay, that can be done using 𝗘𝘅𝗃. Second thing that it's going to find is to perform dependency check. What is dependency check? As I mentioned, dependencies are mentioned inside the pom.xml, package.json, requirement.txt or .cs proj file in case of .NET. So the dependencies that we need to use for the application, it is possible that some of the dependencies might be outdated, some may be vulnerable, or some kind of issues might be with those dependencies. So that information immediately will be provided to us by 𝗘𝘅𝗃. 𝗘𝘅𝗃 will let us know which dependency is outdated, which one is not safe to use, and it will give us an alternative also. Instead of this dependency, you can use the other one. Okay, so this will be the first level of security that we are going to do, which is file system scan and dependency check. Okay, after that we have 𝗘𝘅𝗃𝗃 analysis. So what we are going to do in case of 𝗘𝘅𝗃𝗃 analysis, two things happen in case of 𝗘𝘅𝗃𝗃 analysis. Okay, first is known as code quality check and second is known as code coverage. What is code quality check? So it is possible that inside our source code, we might be having some bugs, we might be having some vulnerabilities. This I'm talking about the source code. Okay, so bugs we might be having, vulnerabilities we might be having, code smell we might be having, or these kind of any other issues that might be present in our code, that will be found out clearly, like in which line there is an issue. That will be found out by 𝗘𝘅𝗃𝗃. Okay, 𝗘𝘅𝗃𝗃 is going to scan your whole code, your application code, and going to find out, basically perform a code quality check. So how do we know if quality is better or not? So basically, if your application code has very less number of issues like bugs, okay, bugs or vulnerabilities or those things. So if there is very less number of those things, then we say that okay, it's good, quality is good. If number is more, then we say code quality is not good. Okay, Second thing that SonarQube is going to do is known as code coverage. Okay. Now, code coverage is what? So basically, let's say we have run unit test cases, and let's say I have run 10 unit test cases, and it is able to cover or test around 80% of application code. Okay. Then we say that 80% is code coverage. Okay. So that information will also be provided by SonarQube, and that's why we are running SonarQube after unit test cases, so that the test cases report will be available for SonarQube to generate the code coverage. Okay. After that, we have code quality check. Now, how do we know that, okay, the analysis that we done just now, so is it good? Like it should be passed. Passed means if our code, if the code coverage is 80%, then we will say, okay, it is good, code is good. Okay. So those checking of these things, like the some kind of, you can say, threshold. Okay, threshold means ki, okay, if duplication in our code, if duplication is like just 4% or below it, then it's good. Okay, so these kind of parameters we can define using quality gate check. Okay, that will be just after SonarQube. So once these things are done, here as of now, here we are not building anything. Next step, we start building the application. Okay, let's say if we have a Java based application, so if I run build command, it's going to generate a artifact known as jar or var file. Once we have jar or var file, then we can proceed next. What is jar and var? These are like actually application packages. Okay, they are actually for example, if you have little bit experience in Java, you might know how we can run a Java program. We run in this format: java -jar, then app.jar. Okay, so once we get the jar file, we can run the application in this format. Okay, that is one thing. Moving next, so once we have built the application, we have the jar file, var file ready, right? But in order to keep these jar or var files safely, what we can do, we can publish these artifacts to artifact repository tool, which is known as Nexus. Okay, so we can publish it to tool like Nexus, and we can store them. Okay, there are other formats also can be stored, like for Python also we have option, for Node.js we have option, for like if we have nugget files, for that also we can publish it or upload it to Nexus. Okay, so that will be next step. After that, what we do, once we application built, we can start building the Docker image. Okay, and as I say, this is a DevSecOps pipeline. That means almost at every stage we are going to make sure that everything is secure. So once we have built Docker image, what I want, that Docker image should also be scanned to find out vulnerabilities if it does have or not. That also we can do using 𝗘𝗅𝗏. Okay, same tool that we used here. Okay, because this tool is quite versatile and it has lot of options. Okay, so using this tool, we can scan our Docker image to find out if it has issues or not. If the issues are critical, we will inform immediately to our developer team and ask them to fix the code. Okay, after that, if everything is fine, we can push our source code to our Docker Hub repository or any private Docker registry. Okay, depending on the requirement. Once we have done that, then we need to, after that, we need to make sure that we have YAML manifest files. What are these? These are the actual configuration file using which we can deploy our application to a cluster like EKS. Okay, so let's say once we have this, once we have built our Docker image and we have YAML manifest file, then we can deploy the application to EKS. Okay, once we deploy the application to EKS, then application in few seconds it will start to run. Okay, and after running, it will look something like this. Let's say application is running, right? So after that, what is going to happen? Last stage will be notification email. We are going to receive notification that if pipeline is success or a failed. Based on that, we can understand what happened, right? So after every pipeline, we are going to get notified over our email address that, okay, pipeline is success or failed or anything, right? Like that. Okay, now this part is basically, this was DevSecOps part where we build and deploy the application. Now comes, once application is deployed, we need to monitor it also, right? So when we talk about like just monitoring the application, okay, there are many different kind of monitoring. I'll explain one of them. We have one tool known as black box exporter. Okay, so inside black box exporter, we can provide the URL of the application wherever it is running, and then ask black box exporter to monitor the application if it is running 24/7 or not. If the application goes down, if the URL, if like basically if I hit the URL www.xyz.com and application is not coming, that means application is down. So immediately black box exporter, what it's going to do, it's going to first of all inform alert manager, and alert manager is going to let us know that, okay, application is down. Immediately we'll be notified. Okay. Also, black box exporter will be connected to Prometheus, and Prometheus will be connected to Grafana, so that we can do live monitoring also. Okay, so that whatever data this black box exporter is having or getting based on this website URL, we will be able to see in our Grafana dashboard if application is like working fine or not, if it is running or not. Okay, so in this way we will be always notified even after the deployment, and even if anything goes wrong, we will be still uh, uh, like notified. Okay, so this is the actual process that happens in companies, and this is the actual flow. Okay, and same flow I'll be teaching in my course also. So as I say, you can check it out. If interested, you can enroll. Okay, now yeah, that's all for today, team, and I'll prepare a documentation for this as well, so that you can like go through it as per your own requirement. Okay, so yeah, thanks for watching, team, and have a nice day.